This video is about the Angle Bisector Theorem. If you'll notice in this diagram, even though it's not stated in the instructions, we have an angle bisector because the two little red lines mean that these two angles are equal to each other. So the large angle of this triangle has been split into two equal pieces. What the angle bisector theorem says is that an angle bisector, so that's this line segment, divides the side, where we have the 12 and the 27, into two pieces that are proportional to the sides that they're adjacent to. Now, that might sound like a mouthful, but really it says something simple. This angle bisector divides this side into one piece of length 12. Well, this piece, if you compare it to the side that it's next to, 3x plus 4, is in the same proportion as the other piece, 27, is to the side that it's next to. So at the end of the day, all that you have to do when you're dealing with an angle bisector is you write a proportion equation. So if you look at the sides in blue, if you compare 12 to 3x plus 4, that's in the same proportion as if you compare 27 to 36. Now solve this proportion equation. If you're just going to solve it in a calculator, I guess you could stop there. This one isn't that hard to solve by hand. Before I would do anything, I would notice that, well, 9 goes into both 27 and 36, so you could say 12 over 3x plus 4 equals, well, 27 divided by 9 is 3, 36 divided by 9 is 4. So now, if you cross multiply, I really don't like that phrase, but it does work when you're solving a proportion equation. So if you want to cross multiply, 12 times 4 is 48, and then we have 3 times 3x plus 4. Now just solve this equation. We have 48 equals 9x plus 12. Subtract 12 from both sides. 36 equals 9x. Now divide by 9, and you get x equals 4. And we're done. So if you want to look at this example, pause the video. I'm about to do one that's just a little bit more complicated. So here we have the same idea. This is an angle bisector. So this part, labeled with the 6, when we write a proportion comparing it with this side labeled with 10, that's going to be in the same proportion as this part, which doesn't have a label, if you'll notice, compared to the side that it's next to, labeled with the 15. So the key is, well, I already said it, this part on the right doesn't have a label. We have the entire side, and we know that this part is 6, so you have to subtract. So this part on the right is x plus 5 minus 6, or x minus 1. Once you do that, you're done. You continue just like we did in the prior question. We'll compare 6 to 10. 6 compares to 10. And then on the right-hand side, x minus 1 compares to 15. So you could solve this equation, again, in the calculator if you like, or by hand. I'll go ahead and solve this by hand. I would reduce the fraction. 6 and 10 are both multiples of 2. 6 divided by 2 is 3. 10 divided by 2 is 5. And there's nothing I can do on the right-hand side. And here's one reason why I don't like the phrase cross multiply. There's no reason to cross multiply here. All you have to do, if you multiply by 15 on both sides, well, what happens on the right-hand side is the 15 cancels. That's what we wanted to happen. However, 15 cancels with 5, leaving you with 3, and then 3 times 3 is 9. So really quickly, you get to 9 equals x minus 1, therefore x equals 10. So this is how you use the angle bisector theorem to write down proportion equations. Hope this helped. See you next time.